Good afternoon, everyone. It's a pleasure for me to be here as this new edition of ISONTech. For the one that were present here last year, you might remember that my colleague Tom McGrath introduced to you the Philip Morris portfolio in the product with a potential to reduce risk. Today, I will introduce to you in particular the mesh technology, which is one of our products in the eVapor category. So mapping out the e-cigarette portfolio in the UK market, we can really differentiate three segments in the e-cigarette category, and that will be the disposables, the closed tank or the cartridges, and the open tanks. PMI products that are present in some of the markets are under the brand Nicotine and Vivid. So in 2014, PMI acquired Nicosig, an e-cigarette leading company in UK that produces products in the e-cigarette category under the brand Vivid and Nicosig. In 2013, Altria Group made available exclusively for PMI its e-cigarette to be commercialized outside of the US under the brand Solaris, which is present today in Spain and in Israel. So even though there is a broad portfolio and a wide choice for the consumer, for the adult e-vapors, there is a constant and a current concern about the quality, the safety, the consistency, and the origin of the e-cigarette. Therefore, PMI engaged in the development of a new innovative portfolio in the nicotine-containing product, fulfilling the quality requirements and matching the consumer needs. This can be achieved by ensuring the development of a fully automated manufacturing process by having in mind quality-minded industrialization processes. So here I present to you the mesh technology, which is an eVapor product. So we have a e-liquid aerosol generation, a complex flavor system, and an electronic device. The eVapor working principle is well known today. So we talk about the evaporation, the condensation of e-liquids. E-liquids that are made of water, vegetable glycerin and propylene glycol, nicotine and flavors. We talk about the power supply. Today, most of the products are battery operated. And the heater that is activated on demand, which could be a button or a puff sensor. So the e-liquid, we have the e-liquid in the reservoir that is transported through the transport material and retained on the heating engine, which can be a coil or a mesh, where the evaporation of the liquid happens and the aerosol is formed and then transported to the mouthpiece. Looking back at these working principles of e-cigarettes, we identified three pillars to ensure the good quality of the aerosol. So here we talk about the control over the e-liquid quality, and that can be ensured having a closed tank system and by following quality standards for the e-liquid manufacturing. A good contact and a permanent contact between the e-liquid and the heating element will really provide a good quality aerosol and a consistent aerosol. And of course, what is most important is really the detection of the cartridge end of life. What does it mean? It's a low liquid detection to really prevent the formation of the harmful and potential harmful constituents. So mesh is the product that has been launched by PMI at the end of 2016 as a city test in Birmingham, UK. What we propose to the adult vapors are 8 SKUs, 4 flavors, tobacco, menthol, chai in the creative category, and the tropical fruits, 2 nicotine levels. The cartridge contains 2 milliliters of liquid, ensuring about 370 puffs. The manufacturing of e-liquid is taking place in Netherlands. The cartridge, what we call the consumable, it is manufactured in Italy in our European premises, and the device, it is assembled in Malaysia. The mesh working principle is not so different from a weekend coil, so we still have an e-liquid reservoir. The liquid is applied by capillarity and gravity to the mesh patch. The airflow, where the evaporization happens, the airflow carries the vapors passing over the mesh patch. When you look at the construction of the cartridge, so we have the e-liquid reservoir into the cartridge. We have what we call the mesh heater assembly, which has a high retention material. We have a transportation material to the mesh and the mesh cap or the mesh heater. The splash cap is there to ensure a proper sealing of the product and assembling of the cartridge. The key features for mesh, looking at the construction of the cartridge and the heating element that is on a flat geometry, it really allows a fully automation into the manufacturing process. And that will allow quality, reliability, and reproducibility in the aerosol performance. The dry mesh detection, or what we call the low liquid detection, it's a feature that will prevent the e-liquid degradation towards the cartridge end of life. So in this case, the harmful and the potential harmful constituents will be fully controlled over the complete cartridge life cycle. The homogeneous distribution over the complete mesh patch, it's another key feature that allows us to precisely control the aerosolization temperature and ensure the RRP quality. A constant power supply over the heater during the battery discharge cycle. It really allows consistent aerosol deliveries at any device and any cartridge life cycle. And the puff on demand, which can be activated with a puff sensor present in the device. In this way, the puff duration can be monitored and controlled by the electronics. So I've been talking about the consistent aerosol, and this chart is really describing and presenting to you how the aerosol deliveries compare to the weekend coil technologies. So you see in the blue vertical bars, these are the aerosol deliveries for the mesh per groups of puffs and along the cartridge life cycle. The other color lines shows the deliveries for the weekend coil product, where towards the end of the cartridge life cycle, we see a decrease in the aerosol deliveries. So these constant deliveries can be really achieved with our mesh technology. Sorry. Looking at the formaldehyde, which is a marker for overheating of the e-liquid, here we plot where the formaldehyde levels are present for the mesh product, which is the blue line that you see below. In the red, you will see the 3R4X, the conventional cigarettes. And then we see for the weekend coil product an increase of the formaldehyde levels towards the end of the cartridge life due to the fact that the low liquid detection is not present in this kind of product. Looking at the broader representation of formaldehyde levels in comparison to the market maps for the tank using reference e-liquid, here we have plotted the maximum market map in the blue line. In the orange line is the minimum of the market map, and the red line the average. You will see the points below are two of the mesh products where for the entire cartridge life cycle, the formaldehyde level remained very, very low. Another contributor into ensuring a good quality and a consistent aerosol is really the fully assembly automated process. So here is an exemplification of our machine Genesis, which it is installed in our European premises in Italy. So the main steps during the assembly process, we have an automatic cartridge filling with the e-liquid. We have a mesh heater sub-assembly. So we have the mesh heater that will be assembled together with the retention material and the transport material. And then everything will be sealed and capped by the splash cap. We have visual controls for each of the steps in the manufacturing process to really ensure a good quality and a good control during the manufacturing. So the key messages that I wanted to share with you today is that these three elements that are represented here, that are the mesh heating element that has this flat geometry and has the capacity to increase the surface area and the contact with the e-liquid, is one of the main features of the mesh technology. The heat control technology, so the smart electronics that will control and maintain the temperature in around 200 and 220 degrees to ensure a consistent deliveries of the aerosol. And the low liquid detection system, which is really the key feature for preventing the generation of the harmful and potential harmful constituents, are the main pillars, and these technological innovations coupled with the automated assembly, ensure that the mesh heats the e-liquid consistently, resulting in the delivery of a high-quality, satisfying eVapor. So with that, I conclude my presentation today. If you are interested, you can go on the PMI Science website and hear more about all four platforms that PMI is developing in its portfolio. And we have posters that are presented during these 2 days. And for any other questions, thank you very much.